Can we cross the universe in seconds? If wormholes are real, maybe. A wormhole or Einstein-Rosen bridge is a theoretical tunnel that connects two distant points in space-time. If it exists, it could reduce light years to mere seconds. But we've never seen one. And even if it exists, could humans survive the journey? Gravity, radiation, and quantum instability could tear us apart. Wormholes, the future of space travel or just sci-fi fiction? Follow for the next twist in the space-time saga. A delicate beginning. Was the universe fine-tuned for life? There is a silent mystery woven into every line of a physics equation, every beam of light passing through the lens of a space telescope. Why is the universe so perfectly tailored for life? Scientists call this the fine-tuning problem. And this problem isn't hidden in some distant galaxy. It lies embedded within the very numbers that define the universe. Imagine if gravity, the force that keeps Earth orbiting the sun, were just 1 part in 10 million trillion stronger. Stars would collapse and explode far too quickly to forge heavy elements like carbon, oxygen, and iron, the essential ingredients for life. If the Planck constant, which governs quantum effects, were even slightly different, the entire framework of quantum mechanics would fall apart. Atoms wouldn't be stable, and molecules could never form. If the fine structure constant, which represents the strength of electromagnetic interactions, were just a bit stronger, electrons would be pulled too tightly into atomic nuclei, making chemical reactions as we know them impossible. Or if the mass ratio of protons to neutrons differed by just a few thousandths, nuclear fusion inside stars wouldn't occur properly, resulting in no carbon, no water, no DNA, and no you. All of this leads to a haunting conclusion. The universe we inhabit seems to be exquisitely tuned to allow life to exist. So then, who tuned it? There are two major hypotheses, each taking us down a very different path of thought. One sacred, one rooted in cold probability. The first is known as intelligent design. It argues that the level of precision we observe is far too exact to be a result of chance. Some scientists and philosophers like Paul Davies or earlier Isaac Newton have proposed that the universe is like a grand clock, and where there is a clock, there must be a clockmaker. Could there be a transcendent intelligence, beyond space and time, that carefully programmed the physical constants so life could flourish? Yet, this hypothesis quickly runs into a difficult question. If the universe requires a designer, then who designed the designer? And if we keep asking backward in this way, do we end up in an infinite chain of causes? Or must we finally accept something that simply exists by itself, uncaused? The second hypothesis comes from modern theoretical physics, the multiverse. Instead of assuming our universe was specially designed, this theory suggests that there are countless universes, each with its own set of physical parameters. Most of these universes are utterly lifeless, where gravity is too strong, where matter is unstable, where time flows unpredictably, and only a rare few like ours happen to have just the right conditions. And because only those universes that allow life will have observers within them, our perception of a fine-tuned universe isn't evidence of design. It's simply because we're in the only place where such a question can be asked. This is the essence of what is called the anthropic principle. In the end, whether you believe the universe is a grand symphony composed by an invisible conductor, or a random flicker in the infinite data stream of a multiverse, one thing is undeniable. The universe you are in is astonishingly, unimaginably rare. It doesn't just seem reasonable. It is so reasonable, it sends shivers down the spine. Quantum mechanics and the emergence of consciousness. For centuries, modern science has been built upon what seemed like an unshakable foundation. Reality exists objectively and independently of the observer. A stone will fall whether or not you see it. A planet will continue orbiting its star, even if no one is there to witness it. But then came quantum mechanics, like a bolt of lightning striking that solid foundation. The double-slit experiment, a doorway to paradox. One of the most famous and controversial experiments in the history of physics is the double-slit experiment, first performed with light by Thomas Young in 1801, and later applied to particles such as electrons and atoms. When individual electrons are fired at a screen with two slits, and no measurement is made, the particles behave like waves. They create an interference pattern, just like ripples on water overlapping. This suggests that each electron somehow goes through both slits at once, existing as a probability wave. But the moment a detector is placed to observe which slit the electron passes through, the wave pattern vanishes. The electron chooses one slit only, behaving like a tiny particle. The result: the interference pattern disappears, replaced by two simple bands. The paradox? Observation, a seemingly harmless act, has changed the outcome. Reality, in some mysterious way, seems to choose a state when being observed. The hypothesis: does consciousness create reality? Some physicists and philosophers have raised a profound question. Could it be that consciousness itself, not just the measuring device, is what collapses the quantum wave function, thereby giving birth to concrete reality? Nobel Prize-winning physicist Eugene Wigner once proposed the idea that there can be no true quantum measurement without a conscious observer. According to this interpretation, the state of matter, its position, momentum, even its very existence, is not real until consciousness arises to observe and measure it. Before observation, the world is merely a cloud of probabilities, uncertain, overlapping, undefined. It's as if the universe exists in a state of potentiality until the light of consciousness shines upon it, and only then does it become real. The many worlds interpretation, every possibility happens. However, not everyone agrees with giving human consciousness the power to create reality. A bold alternative is the many worlds interpretation, proposed by Hugh Everett III in 1957. According to this view, every time a quantum event occurs, say an electron could go through either the left or right slit, both outcomes happen but in separate universes. The universe doesn't collapse into one choice. Instead, it splits, branching into countless parallel worlds where every possibility is realized. In this model, no consciousness is needed to collapse the wave function. In fact, nothing collapses, the universe just keeps dividing endlessly. So, what is consciousness in this picture? If we follow the classical view, consciousness is a byproduct of the brain, evolved for survival. But if we accept the quantum consciousness hypothesis, then consciousness becomes something far more, the very force that shapes reality, the center of all physical models. A more poetic and radical idea suggests the universe is not a place that contains consciousness. Consciousness is how the universe sees itself. When you look up at the night sky, you're not merely observing the stars. You are the universe looking back at itself, a flash of awareness in the eternal darkness. We don't yet have a definitive answer. But one thing is clear: quantum mechanics doesn't just shake our understanding of matter. It forces us to confront an even deeper question. Is consciousness a fundamental part of reality itself? If the answer is yes, then the universe is not just a lifeless machine. It is a being that observes itself, through your eyes, through mine, through all the living minds that dare to ask, why? Entropy, time, chaos, and the price of order. If there is one law in physics that feels truly eternal, it is the second law of thermodynamics. It states that entropy, the measure of disorder, in a closed system tends to increase over time. This means order gradually dissolves, usable energy becomes increasingly scarce, and eventually, the universe will reach a state where all physical processes cease. A scenario known as the heat death of the universe. In a universe that dies by entropy, all stars have burned out. No more meaningful motion, no more energy to do work, no more life, only a cold, dark blanket draped over infinite space. That sounds reasonable, but then comes the problem. If entropy always increases, why did the universe begin in a state of extremely low entropy? Why was the moment of creation so pure, so ordered, so special that the odds of it happening were just a tiny fraction among billions upon billions of possibilities? Physicist Roger Penrose, collaborator of Stephen Hawking, once estimated that the probability of the universe starting with the current level of low entropy is 1 in 10 carat 10 carat 123. A number so vast that even if we used every atom in the universe as a digit, we still couldn't write out all the zeros. So the question is, why didn't chaos win from the very beginning? Why didn't the universe start in a messy, high-entropy state, as would seem more natural? Enter one of the strangest hypotheses in the history of physics, the Boltzmann brain paradox. According to 19th century physicist Ludwig Boltzmann, temporary pockets of order can emerge spontaneously due to random fluctuations within a chaotic environment, much like gas molecules suddenly clustering into a perfect sphere. While incredibly rare, it's not impossible. But here's the twist. The minimum requirement to produce a conscious observer is much smaller than the requirement for an entire structured universe like ours. In other words, it's far more likely, statistically speaking, for a random fluctuation to produce a single isolated brain, complete with false memories, a sense of life and the thought "I exist," than it is to produce a full universe with stars, planets, and billions of years of evolution. This is the paradox. Because if we really trust pure statistics, then maybe we're not living in a universe born from the Big Bang at all. Maybe we are just a fleeting illusion, a Boltzmann brain, floating in chaos, that just popped into existence and will vanish again in the next instant. And all your memories of Earth, of human history, of science, love, and beauty, they're nothing more than temporary data in a passing quantum glitch. So what are you? A real living being, born in a vast, orderly universe, shaped by billions of years of evolution? Or a fabricated memory, reminiscing about a world that never existed? Of course, most scientists reject the Boltzmann brain as a serious explanation for human existence. But what makes the paradox so unsettling is not its strangeness. It's the fact that it logically follows from the assumptions used in classical physics. It forces us to ask, does the universe really follow the laws we think it does? Is time truly a one-way arrow? Is order a miracle pre-installed at the beginning of time? Or merely an illusion born out of unstable chaos? In the end, entropy is not just a problem of physics. It's a fundamental question about time, about the reality of memory, and about the very nature of existence. And in the shadow of paradoxes like the Boltzmann brain, we're left with a bitter yet oddly beautiful realization. We cannot be certain that we are real, but it is precisely this doubt that makes our experience feel most real of all. Infinity and the unbearable question. Infinity is one of the strangest concepts ever conceived by the human mind. It is beautiful, profound, and full of possibility, but at the same time, it is a deep crack in our finite way of thinking. Unlike any other quantity in mathematics or physics, infinity cannot be measured, cannot be fully imagined, and certainly cannot be verified. And yet, the absurd happened. Modern cosmology now seriously considers that space, the universe itself, may be infinite. According to the flat universe model, based on data from the WMAP and Planck telescopes, scientists have found that the universe shows no detectable curvature, meaning it's not curved like a sphere, nor closed like a loop, but seems to stretch endlessly in every direction. The inescapable consequence of an infinite universe. Now pause for a moment and imagine, if space is truly infinite, and if the laws of physics are uniform throughout the cosmos, as all current theories assume, then one bizarre but inevitable consequence emerges. Every possible configuration of matter must exist, and must exist infinitely many times. This means that somewhere, out there in that infinite cosmos, there exists another Earth exactly like ours, with the same Andes Mountains, the same ancient town of Hoi, and the same World War II history, not a single detail different. On that planet, another version of you is sitting, at this very moment, reading these exact same words. And further still, there exists another version of you, but one who didn't choose the same career, didn't fall in love with the person you did, didn't send this question. Someone who took a different path and is living an entirely different life. This is not poetic science fiction. It is a mathematical consequence of combining an infinite universe with the rules of quantum mechanics. Cosmologist Max Tegmark from MIT once wrote, "In an infinite universe, even the most bizarre things not only can happen, they must happen, and happen infinitely many times. But if you are repeated infinitely, can you still call yourself unique?" This is where human reasoning begins to falter. In a finite world, the idea of a self, of a unique me, is the foundation of all values. Love, sacrifice, responsibility, identity. But if there are countless other versions of you, living countless other lives, is the you cherish still real, or merely a neurological illusion to guard against metaphysical despair? What defines truth? If every possibility is realized somewhere, is your pain still sacred? If another version of you is currently happy, does your choice matter? If the universe instantly spawns another you who chose the opposite? And worse, if every version of you exists in parallel, what makes this version, you, right now, the one worth believing in? The mirror room of infinity. An infinite universe is like a room of mirrors, where every action is echoed endlessly. Physicists once believed the universe was a story with a beginning, the Big Bang, and an end, heat death. But if space is infinite, if the multiverse is real, and quantum mechanics allows all possibilities, then reality is no longer a linear flow, but a complex map where every point connects to every other point. The question, are you still unique, is not a philosophical curiosity. It is the inescapable consequence of what modern physics is beginning to suggest. And if the answer is no, then our entire framework of ethics, identity, even faith and personal choice must be re-examined. And that is what makes infinity not just awe-inspiring, but utterly unbearable. The universe, an information system, not a collection of physical particles? Since ancient times, humans have tried to define reality through tangible elements: earth, water, fire, and air. Then came Newtonian physics, which imagined the universe as a giant machine, where all objects were made of particles moving in space, governed by deterministic laws. But today, as physics dives into the subatomic realm and information technology reaches the power to simulate reality itself, a new question arises, both terrifying and mesmerizing. Could what we call reality be nothing more than information? Light bulb it from bit. Everything that exists comes from bits. Legendary physicist John Archibald Wheeler, a collaborator of Einstein and one of the founders of quantum gravity theory, once made a bold declaration. It from bit. That is, everything in the universe, from quarks to black holes, originates from information bits. According to Wheeler, physical reality is not fundamental. It is merely the surface expression of a deeper informational structure. He was not alone. Quantum engineer and physicist Seth Lloyd of MIT took this idea even further, describing the entire universe as a giant quantum computer, in which every physical process is an act of information processing. In his book, Programming the Universe, Lloyd writes, "Every photon, every particle collision, every chemical reaction is a computation. The universe is computing itself. If this is true, then matter is just the graphical interface. Much like a character in a video game is unaware that it's merely code rendered on a screen, we too might be nothing more than the temporary display of an underlying informational substrate. Is the universe a simulation?" Following this line of thought, an even more provocative hypothesis emerges. What if the universe we live in is a digital simulation? This idea was popularized by Nick Bostrom, a philosopher at Oxford University. In his famous essay, Are You Living in a Computer Simulation?, Bostrom argues that if any civilization became advanced enough to simulate entire universes, and if they had reasons to run billions of such simulations, then the probability that we are living in the base reality becomes vanishingly small. In other words, we are almost certainly living inside a simulated world. Even Elon Musk, not a physicist but known for his deep interest in technology and the future, has famously said, "The odds that we're in base reality are 1 in billions. It's far more likely we're in a simulation." But if this is a simulation, who wrote the code? That is perhaps the most terrifying question of all. If the universe is software, who wrote the software? If all things are just an interface, what is the infrastructure running underneath? Is there a server operating this simulation? And if so, does it exist in a higher layer of reality? Or is it itself just a simulation within another simulation? We fall into an inescapable loop of logic, like someone dreaming, who wakes into another dream, only to dream again. Each layer we dig through only reveals another constructed level of reality, never the bottom. And in that spiraling recursion, our belief in what is real begins to disintegrate. If the universe is information, not matter, not energy, not fields, then everything we've ever believed about reality must be rewritten from scratch. We are not simply living in a physical world, but existing within a process of formless data processing. where consciousness, memory, space, and time are all just interfaces through which something deeper is operating. The question is no longer, is the universe real? But rather, is there something beyond even real? Something that powers every model of reality we've ever known? Consciousness, a fundamental phenomenon or a byproduct? Let's set aside equations, constants, curved spacetime models, and multiverse theories for a moment. Because in the end, none of those concepts, from quantum fields to black holes, would ever appear without one thing: consciousness. The issue is no longer, how does the universe work? But rather, who is asking that question? Why does an ape understand the cosmos? This is a strange paradox that many modern philosophers and physicists still struggle to explain. The human brain, in theory, was shaped by evolution, a blind, cold process concerned only with survival and reproduction. We are creatures optimized to hunt prey, avoid predators, and find mates on the African savanna. Yet somehow, that same brain wrote down the equations of general relativity and predicted black holes before there was any observational evidence. It contemplates the birth of the universe, curved spacetime, multiverse models, and the eventual heat death of a cosmos billions of light years away. Why would a creature evolve to gather food? Imagine 11-dimensional space. Why would a finite biological machine ponder the infinite? That question cuts to the heart of all cognitive systems. What is consciousness? And where does it come from? Magnifying glass tilted left. Possibility 1. Consciousness is a byproduct of matter. According to the dominant view in modern science, especially in neuroscience, consciousness is a byproduct of information processing in the brain. There's nothing mystical about it. It is merely an illusion arising from the interaction of neurons, neurotransmitters, and synaptic networks. This view is known as materialism, more specifically reductive materialism. According to it, the mind is the brain, and everything from emotion, memory, soul to love is just the result of electrical signals and chemical reactions inside our skull. This framework has been extremely effective in medicine and technology, from treating depression to building artificial intelligence. But it hits a massive wall, the one philosophy calls the hard problem of consciousness. The problem: why is there subjective experience at all? Philosopher David Chalmers, who coined the term, pointed out, even if we perfectly describe all the physical activity of the brain, we still can't explain why we feel anything. Why does red appear red? Why are we aware of being alive? Why does pain hurt? These inner experiences, known as qualia, appear nowhere in any physical equation. They are subjective, internal realities, and they remain the blind spot of materialist science. Possibility 2. Consciousness is a fundamental property of the universe. This is where a bold and radical hypothesis emerges, one that completely inverts the conventional view. Instead of treating consciousness as an effect of matter, this view treats consciousness as a foundational principle, like space, time, energy, or information. Consciousness is not produced by the brain. The brain is merely a tool for accessing a level of awareness that already exists. This perspective is called panpsychism, the idea that mind or awareness is embedded throughout the fabric of the universe. And it is gradually experiencing a revival in both philosophy and quantum physics. Quantum physics and the role of the observer. As mentioned in the previous section, in quantum mechanics, the state of a particle isn't real until it is measured, which implies that conscious observation plays a critical role in defining reality. This has led some physicists, such as Roger Penrose and Stuart Hameroff, to propose that consciousness is not a byproduct of the brain, but part of the quantum structure of the universe itself. They developed the orchestroar theory, where quantum processes within the microtubules of neurons may give rise to subjective experience. Though not yet fully proven, this model suggests that consciousness could be a quantum phenomenon, and therefore not bound entirely by classical physical rules. We don't yet have a definitive answer, but what's certain is this: consciousness is not a trivial phenomenon. It is the foundation of all knowing, because without consciousness, there is no knower. Physics, philosophy, love, and poetry all begin from a mind questioning itself. So, if one day science proves that matter is just a surface manifestation, and consciousness is the deep essence of the universe, then that discovery would not be a shock, but a homecoming, a return to what we have always been long before the word "we" ever existed. An open conclusion. Design? Spontaneity? Or nothing at all? After all the journeys through layers of reality, from quantum mechanics to entropy, from multiverses to simulation models, from physical particles to consciousness, we arrive at the final frontier. Does this universe have a purpose? Or not at all? And the answer, paradoxically, doesn't lie in certainty, but in three grand possibilities, coexisting like diverging branches of an unsolved equation. First possibility, the universe is designed by a cosmic intelligence. This is the oldest hypothesis, yet strangely compelling in the quantum age. When we confront the breathtaking fine-tuning of physical constants, the gravitational constant, Planck's constant, or the proton-neutron mass ratio, all seemingly just right in an improbable way that allows life to exist, the natural question arises, is this random or the work of intelligence? Scientists like Paul Davies and Freeman Dyson have suggested that the level of fine-tuning defies simple probabilistic explanation. Even Einstein, not a religious man, once said, "I want to know whether he had any choice in the creation of the world." In this view, the universe resembles a program written by a metaphysical programmer, in which every variable has been carefully chosen to enable consciousness to emerge and reflect back on the program itself. Second possibility. The universe is spontaneous, no intention, no purpose. This is the coldest yet simplest model, and the one most of the modern scientific community provisionally accepts. The universe emerged spontaneously from a singularity, the Big Bang, driven by quantum fluctuations in a vacuum, without intention or goal. According to quantum field theory, even nothingness, or vacuum, contains energy. Random fluctuations in this quantum vacuum can produce particle-antiparticle pairs. Some tiny asymmetry, 13.8 billion years ago, may have broken the balance and given birth to matter, light, space, and time. From there, everything evolved through natural selection, particle collisions, the cooling of plasma, the formation of atoms, stars, planets, and eventually life and us. In this model, human consciousness plays no special role in the big picture. It is merely a byproduct, an epiphenomenon, that arises temporarily from chemical interactions in a carbon-based biological machine, lives 80 years, then fades. It is an atheistic worldview without comfort, without destiny, but one that is highly rational. Third possibility. The universe is an information processing system, and reality is just its output. At the intersection of philosophy and modern physics, a new hypothesis is emerging. Reality is the result of computation. According to quantum physicist Seth Lloyd, the universe doesn't just resemble a computer, it is a computer. Every event, from the collapse of a quantum wave function to planetary motion, is a step in data processing. Matter, energy, and fundamental forces are nothing more than temporary structures rendered from a deeper, invisible layer of information. If this is true, then we and everything we perceive are merely the output interface of a computation. This universe doesn't need a designer, nor does it need intent. It simply runs. But like all software, if there's a computation, there must be an initialization function. If there's an algorithm, there must be an operating system. And from here, the most unsettling question arises. Who wrote the source code? And what or who is running the program? Once again, we fall into an endless loop of logic. We don't know what the universe truly is. Even less do we know why it somehow came to ask about itself through human consciousness. But perhaps the most important realization is this. We are reaching the limits, not just of knowledge, but of modern ways of thinking. Perhaps the scientific method, for all its greatness, is only one tool within a larger data set that we cannot yet imagine. Perhaps the question, why is there something rather than nothing, is not meant to be answered with formulas, but with silence. And sometimes, amidst unsolved equations, amidst wave-like theories flickering in and out of coherence, amidst parallel visions of reality, we may have to accept that the greatest beauty of the universe does not lie in its answers, but in the fact that we keep asking. Do you know what you're living in? Whether you believe in design or randomness, remember this. You are the living embodiment of an ancient universe, trying to understand itself. The journey to understand the cosmos is not just a pursuit of knowledge, but an act of faith, intellect, and humility. And if there's anything that makes you truly magnificent, it's the courage to ask questions in a universe that may never answer.